I'm Justin Bushko from Concise Engineering. In modern medical device product development, if your device includes firmware, embedded software, a mobile app, or a cloud component, you are now operating under IEC 62304, and regulators expect you to prove the software is safe under failure conditions, not just ideal ones. Software is now part of the risk profile, part of the architecture, and part of the regulatory burden, whether you realize it or not. The foundation of IEC 62304 is software safety classification. Class A, Class B, and Class C aren't labels, they determine the rigor of your entire development lifecycle. A Class C system, where a failure could lead to serious injury or death, requires deep architectural documentation, traceable requirements, unit tests, integration tests, fault injection testing, structural coverage evidence, and full verification of every risk control tied to software. Class B still requires disciplined requirements and documented verification. Class A is the lightest, but still demands traceability and clear evidence that hazards cannot cause harm. If your risk analysis identifies any patient harm tied to a software failure, that hazard must be mitigated with traceable, testable software controls. Watchdog timers, alarm behavior, safe state transitions, timeout logic, UI warnings, or interlocks that prevent unsafe conditions. Regulators expect objective evidence, not assumptions. They want reproducible builds, controlled configuration management, and documented code reviews. They expect anomaly tracking with documented resolutions, not bugs that went away when you rebooted the bench unit. They want fault injection results showing how the device behaves when sensors fail, data corrupts, or the system enters unexpected states. IEC 62304 isn't about writing perfect code, it's about proving the system behaves safely even when things go wrong. Software also must integrate with risk management under ISO 14971 and usability engineering under IEC 62366. If software contributes to a hazard, the architecture must show how that hazard is prevented, detected, or mitigated, and verification must demonstrate the control works under worst-case conditions. This is where many startups fail. They build functional prototypes, but not safety-classified, traceable, testable software that can survive regulatory scrutiny. At Concise Engineering, we guide firmware and embedded teams through IEC 62304 expectations while keeping development practical and aligned with real engineering workflows. We help define software requirements, map hazards to controls, build traceability, structure verification, and produce the documentation that regulators expect, without slowing down innovation. If your device includes software, let's build reliability and safety into the architecture from the start.